Hey everyone, in this video we'll show you how to get a report of EDI transactions sent by one specific trading partner by using the AtomSphere API. First we'll look at the request we need to send for this, and then we'll cover how to do it in a Boomi process. So let's get started. Using the AtomSphere API connector, you can get a report of the EDI transactions with errors. For each EDI format, there's a connector record objects such as EDI fact connector record and X12 connector record. Each of these objects can be queried with this AtomSphere API connector. The API allows you to use operators such as between, so that a date range can be used as filter as shown here. Let's take a closer look at the filters we can use to get the EDI transaction records. We'll include at least two filters, so we need to use a nested expression. A nested expression has a logic operator that determines how the expressions work together. It is either AND as shown here, or it has a value of OR. The nested expression is an object in the JSON, and each individual expression within it is an element of the object. You can have nested expressions within nested expressions too, as shown here. For each expression, we need to use an argument operator that tells how the argument value is used in the filter. We can use equals for an exact match of the argument value, or we can use operators like greater than or less than for relative values. Our goal is to get EDI transactions using the partner ID, so we'll use equals operator as well as the between operator to limit the results to a date range. Here is a full query we will use to get X12 connector record objects from a selected partner ID that have either accepted or accepted with errors in the acknowledged status field and were processed within a date range. In our Boomi process, we'll use a HTTP client connector to send the JSON query. We'll set up the JSON in a message shape with the placeholders for dynamic properties so that the dates and partner ID can be changed in the process. While this example shows a query executed for X12 connector record object, the same query could work for any of the EDI connector record objects with almost no change. The basic process we will use is a no data start shape, a set property shape, a message shape, and the HTTP client connector followed by a stop shape. The set properties shape creates three dynamic process properties, one for the start date, one for the end date, and one for the sender ID. It also sets a dynamic document property to be used in the URL for the account ID. The message shape has a JSON text with variable placeholders for the date values and sender ID. The connection for the HTTP client connector is easy to set up. The base URL is the same for everyone, api.boomi.com. The authentication method is basic, but if you use an MFA token for the AtomSphere API, you must include boomi_token dot in front of your username. The token itself goes in the password field. The operation sets the content type, the HTTP method, the accept header, and the resource path using the account ID dynamic document property. That should contain your Boomi account ID. The accept header sets the format of the response, so it is set to application JSON here. When we run the process in test mode, we see the resulting JSON document contains multiple records with quite a few fields. For practical use, it would be best to map the desired fields to a readable file format, then write that out to a disk file. We'll show another option here. First, we'll change the accept header value to application/XML. Even though our request remains in JSON, we can get the response as XML. This makes it possible to use an XSLT style sheet to transform the result into an HTML table. That style sheet shown here writes out only specific elements of the results, making it easier to read. To use the XSLT style sheet, we use the data process shape after the connector. The data process shape has an XSLT style sheet step that uses a style sheet. The result is an HTML file format. Another possibility is to write the result to a delimited flat file for viewing in another application.